Good morning. The Subcommittee on Space will come to order. Without objection, the chair is authorized to declare recesses of the committee at any time. Without objection, the chairman of the Transportation and Infrastructure Committee's Subcommittee on Aviation, Mr. Lobiondo, will be allowed to participate in today's hearing. And welcome to today's hearing entitled Transforming America's Air Travel. I recognize myself for 5 minutes for an opening statement. Before we begin this morning, I want to thank Chairman Lamar Smith and my colleagues for the opportunity to serve as the chairman of the Space Subcommittee. It is truly an honor and a privilege, and my district includes the Johnson Space Center and many of National Aeronautics and Space Administration astronauts, scientists, engineers, technicians, and contractors, and they call the 36th District of Texas home. Because of this, I'm keenly aware of the opportunities and challenges that face NASA and our aerospace sector. I look forward to working with Chairman Smith, Ranking Member Johnson, Ranking Member Edwards, and this Congress. I also want to thank Chairman Palazzo for his leadership during what has been a very busy spring for the Space Subcommittee. Thankfully, he's moving to the Appropriations Subcommittee on Commerce, Science, and Justice, which still has jurisdiction over NASA spending, so I'm certain that we will stay in touch. This year marks the 100th anniversary of the founding of the National Advisory Committee for Aeronautics, also known as NACA, founded in 1915 to supervise and direct the scientific study of the problems of flight with a view to their practical solution. NACA was ultimately incorporated into NASA when Congress passed the National Aeronautics and Space Act of 1958. That same year, Congress also established the Federal Aviation Administration's predecessor, the Federal Aviation Agency. NACA's legacy of civilian aeronautics and aviation research and development is now carried out by NASA and FAA. The aeronautics research carried out by these agencies is vital to our nation's prosperity. Aviation accounts for $1.5 trillion in economic activity and a $78.3 billion positive trade balance. Civil and general aviation is responsible for 11.8 million jobs in the United States and generates 5.4% of our gross domestic product. Put simply, aviation is one of the pillars of our economy. And while we currently enjoy the benefits of our nation's early investments in aeronautics R&D, other nations are now attempting to challenge our leadership. This is particularly troubling when the largest growth sector is not here in the United States, but in Asia. In order to maintain our leadership, we must strategically prioritize our government investments, provide a competitive environment for industry, and coordinate and clearly define public and private sector efforts to maximize efficiencies and minimize duplication that may crowd out investment. If we are successful in these efforts, the potential aerospace breakthroughs in the coming decades are very, very promising. Advances in hypersonic flight could revolutionize the aerospace sector. Continued research into supersonics and air traffic management could greatly reduce flight times. Structural and material research stands to improve safety and save lives. Unmanned aircraft systems, or UAS, research and development could benefit agriculture, search and rescue, fighting forest fires, mapping and surveying, and even package delivery. In order to realize these benefits, we must be ever vigilant. NASA and FAA will have to ensure that the research they support does not duplicate private sector investments. For instance, industry has a considerable incentive to develop safer, more reliable, and more efficient aircraft. Federal intervention and support should be limited to high-risk, high-reward research that the private sector cannot or will not do on their own. Without such prioritization, valuable resources risk being diluted among disparate tasks. This requires a great deal of coordination between NASA and the FAA. Many of the activities that we will be discussing today are conducted by both of these agencies. In 2003, Congress established the Joint Planning Development Office, or or JPDO, to coordinate efforts between NASA, FAA, and other agencies to develop the next generation air transportation system, also known as Next Gen. JPDO functions were recently rolled into the Next Gen Program Office, but the issue highlights an overarching theme that Congress will have to monitor. As budgets tighten, NASA should not be used as a piggy bank for other agency requirements. As many have pointed out in the past, the first A in NASA stands for aeronautics. But we need to be clear. Aeronautics is more than just air traffic management, aviation efficiency, and green fuels. NASA has a long and proud tradition of pushing the boundaries of the possible, a legacy that it should ensure continues into the future. Similarly, we need to ensure that FAA is focused on safety and efficiency. That clearly requires coordination, but hopefully will not cause wasteful duplication or sacrifice the cutting-edge breakthroughs we're used to. Aerospace and aviation research promise many benefits, but not without challenges. NextGen continues to lack clearly defined costs, schedule, and performance parameters. Last year, the FAA Inspector General testified that the initial cost estimate of $40 billion split between federal and private sector investment could double or even triple, and that implementation could take an additional decade. This is unacceptable. Congress either needs better baselines and metrics to track progress or a different plan. In the interim, I fear that valuable R&D funding, the very seed corn of future prosperity, is being used to simply maintain World War II era systems. The challenges are also near term. While Congress waits for next-gen details, reports of potential cyber vulnerabilities to aircraft and next-gen systems proliferate in the press. While recent allegations may be overstated, respected and knowledgeable experts such as the Government Accountability Office and the National Research Council have warned that cybersecurity should play a more prominent role in next-gen development. I want to conclude by thanking our witnesses for being here today to discuss aeronautics and aviation research. This highly esteemed panel will certainly inform the committee's consideration of the research, engineering, and development activities at FAA. I look forward to their testimony and I appreciate their participation. I now recognize Ranking Member, the gentlewoman from Maryland, for an opening statement.
Thank you very much, Mr. Chairman, and good morning, and welcome also to our panel of witnesses. Also welcome to my colleague, Mr. Lobiando, from the Transportation and Infrastructure Committee. Appreciate your participation today. Mr. Chairman, I really want to thank you for calling this hearing to review the current state of U.S. civil aeronautics research and development. But before I begin, I also want to congratulate you on your chairmanship of this committee. I had a wonderful, what started out as a working relationship with former Chairman Palazzo and quickly became a friendship, and I look forward to the same relationship as we move forward. I know that we share many goals, such as maintaining a robust aerospace industry, ensuring that our modernization of the air traffic management system is done safely, and sustaining the strength of NASA and our space program going forward. I look forward to working with you during what remains of this session on identifying the common ground that will enable us to develop policies and legislation reflective of this committee's history of bipartisanship. A century ago, our nation had the foresight to create the National Advisory Committee for Aeronautics, NACA. NACA, which then became NASA, led many breakthroughs in research and design that changed the course of aeronautics and aviation. Today, U.S. civil aviation is a symbol of our nation's ingenuity and ability to design, develop, and manufacture products that are second to none in the world. And as many of my colleagues know, aviation is vital to our economy and to our mobility, as pointed out by the chairman. In fact, the numbers are staggering. Aviation contributes more than $1.5 trillion annually to the U.S. economy. It supports 11.8 million direct and indirect jobs, and it's one of the few U.S. industries that generates a positive trade balance, something we should consider for today. a positive contribution of $78.3 billion in 2014. However, it would be unwise for us to just rest on our laurels. Countries with both mature and less mature capabilities are investing in aviation and aeronautics for their strategic contributions to technology, education, workforce development, and global competitiveness. And the market for air travel is also changing, with growth in the Asia-Pacific region projected to dramatically expand world traffic by 2050. With such growth also come challenges. For example, in 2013, U.S. airlines burned 16 billion gallons of jet fuel, and the cost of delays to U.S. airlines during that same year was $8.1 billion. Increasing fuel efficiency, lessening delays, minimizing negative environmental effects such as noise and carbon emissions are at the heart of strengthening our civil air aviation system. To that end, experts recognized 15 years ago that the existing approach to managing air transportation was becoming operationally obsolete, and there was a strong concern that the national airspace system was approaching capacity. Congress established the Next Generation Air Transportation System Initiative, known as NextGen, in its 2003 Vision 100 Federal Aviation Administration reauthorization to address just these concerns. But over the past 10 years, FAA's overall progress in developing NextGen has been slower than expected, and the agency is now focused on implementing industry recommendations for near-term benefits. Mr. Chairman, research and development is providing the tools FAA will need to implement NextGen and improve the nation's aviation system so that it can respond to changing and expanding transportation needs. Because of the lengthy gestation period needed to move forward from concept to deployment, industry has often been reluctant or unable to apply resources to high-risk fundamental aeronautics R&D, an investment which is the precursor to beginning new technologies and capabilities to market, or bringing them to market. As a result, the federal government, primarily NASA and FAA, in partnership with industry and universities, plays a critical role in carrying out the R&D that enables advances in aviation. So it does concern me, as I'm sure it also concerns the Chairman, that Congress has yet to receive FAA's National Aviation Research Plan for 2015, and even for 2014, despite the fact that those plans are required to be submitted to Congress no later than the time of the President's annual budget submission. Majority and minority members on this committee need those FAA research plans to inform a reauthorization of FAA's research and development activities, to carry out oversight, and to assess the contributions that R&D make to NextGen's implementation. For example, we need to know what kind of R&D activities are planned in cybersecurity, software assurance, human factors, and the certification of new technologies into the national airspace system, all critical areas for the future viability and safety of the national airspace system. So I'm looking forward to hearing from our witness today on the status of aviation R&D activities. Because you see, Mr. Chairman, we need to work together to leverage expertise and capabilities of government, industry, and our universities. Our reliance on aviation is indisputable, but the challenges are steep if we're to maintain our global preeminence as well as the safety of the nation's aviation system. I'm confident that properly funded research by NASA and FAA, in collaboration with industry and university partners, will enable us to achieve that goal. Again, I want to thank our witnesses for appearing before the subcommittee, and I look forward to your testimony. I thank you, and I yield back.
Thank you, Ms. Edwards. I appreciate that, and I, too, am looking forward to working with you. I'd like to introduce our witnesses at this time, and the first witness is Dr. Jawan Shin. He's the NASA Associate Administrator for the Aeronautics Research Mission Directorate. Dr. Shin also co-chairs the National Science and Technology Council's Aeronautics Science and Technology Committee, and is also a member of the FAA Research and Development Advisory Committee. And now I'd like to recognize the gentleman from New Jersey, Mr. Lobiondo, who is the chair of the Aviation Subcommittee. Thank you for being here.
Yes, Mr. Chairman, thank you, and congratulations. Thank you for the opportunity to sit on this hearing this morning. Ms. Edwards, thank you very much. Our committees have a lot in common with a lot of common goals and very important issues to discuss, and that's why I'm very pleased this morning to welcome and introduce Dennis Filler, who is the Director of the Federal Aviation Administration's premier facility in the world for traffic management and federal laboratories. There are almost in total a little bit under 5,000 people, incredibly dedicated people who are very inspiring with the work that they do, again, for the premier facility in the world for safety, security, research, and development. Dennis has an expertise with the FAA, joining it in 1992. He is a United States Military Academy graduate from West Point, and incredible skills in both people management, but maybe more importantly, understanding that which take place that sometimes is extremely complicated. And I enjoy hearing the stories of when some of the incredible, smart engineers are discussing their solutions. Dennis Ashley acts to have the formulas explained to him so he can review their thought process through this. So thank you for allowing Dennis Filler, the FAA's director, to be able to testify today.
Thank you, Mr. Chairman. Appreciate you being here this morning. And Bill Lieber is the co-chair for the committee to review the FAA research plan on certification of new technologies into the National Airspace System. In addition to serving in this position, Mr. Lieber is also the Vice President for Air Traffic Innovations at Passeur Aerospace, Inc. Thank you for being here. Mr. John Hansman is the T. Wilson Professor of Aeronautics and Astronautics at the Massachusetts Institute of Technology, or MIT. He is also the Director of MIT's International Center for Air Transportation and the Chair of FAA's Research and Development Advisory Committee. Dr. Hansman is a Fellow of the American Institute for Aeronautics and Astronautics. Dr. Greg Heislop is the Senior Member at the AIAA and Vice President and General Manager of Boeing Research and Technology and the Chief Engineer for Engineering, Operations, and Technology at the Boeing Company. And I now recognize Dr. Shin for 5 minutes. Dr. Shin.
Good morning, Chairman Babin, Ranking Member Edwards, Chairman Biondo, and Congressman Knight. Thank you so much for this opportunity to testify about NASA's aeronautics R&D activities. NASA's aeronautics research program is making air travel cleaner, safer, and more efficient by developing revolutionary technologies to address a growing demand for mobility, severe challenges to sustainability of energy and the environment, and the advances in information communication and automation technologies. NASA's research directly benefits the passengers and businesses who rely on aviation every day and the U.S. aviation industry to continue to grow and maintain global competitiveness. NASA develops game-changing concepts, algorithms, and technologies to safely increase throughput and efficiency of the national airspace system. We work in close partnership with the FAA and the aviation community to enable and extend the benefits of NextGen. Our research programs also focus on major leaps in the safety, efficiency, and environmental performance of subsonic fixed and rotary wing aircraft to meet growing long-term civil aviation needs, and also pioneering low-boom supersonic flight to achieve new levels of global mobility and sustaining hypersonic competency for national needs. Partnerships are an essential part of NASA aeronautics activities. Our partners include, but are not limited to, other government agencies, U.S. aviation industry, and universities. One of our most important government partners is the FAA. Over the last several years, NASA, the FAA, and other federal agency members of the Joint Planning and Development Office, or JPDO, by working together, defined the vision for the next gen and established a roadmap to get there over the long term. The FAA's Interagency Planning Office continues to lead the coordination of several key technology focus areas, such as the prioritization of UAS-related research and development across federal agencies. NASA's air traffic management research has been developing advanced ATM tools that will enable more accurate predictions about air traffic flow, weather, and routing. NASA also has been working to ensure that these tools work well together and demonstrate the potential of widespread use throughout the system. Our successful model for NASA-FAA collaboration is embodied in Research Transition Teams, or RTTs. RTTs are designed to enhance progress for next-gen advancements in critical areas and effectively transition advanced capabilities to FAA for implementation. RTTs serve as the bridge between NASA's long-term, game-changing technology R&D and the FAA's R&D to support near-term implementation and certification. Under RTTs, NASA and FAA develop joint research plans and fund their respective portions of the planned research according to the nature of the research and their relative capabilities. Over the last 4 years, I'm happy to report that NASA has transitioned to 5 major technologies to FAA. NASA is also researching unmanned aerial systems and more broadly inclusive autonomous systems and technologies. NASA's UAS integration into NAS project is developing technologies that address sense and avoid, communication, and human-machine interaction challenges in order to enable safe and routine UAS access to the NAS. Through close coordination with FAA's UAS Integration Office, industry standards organizations, and international organizations, NASA's research provides validated findings that inform the FAA's policy and rulemaking processes. In order to safely enable widespread small civilian UAS, which are less than 55 pounds, operations at low altitudes, NASA has initiated research in UAS traffic management, or UTM. The goal of UTM is to enable safe and efficient low-altitude airspace operations by providing critical services such as airspace design and geofencing, separation management, weather and wind avoidance, routing, and contingency management. Just as our aeronautics R&D investment over the last 100 years have shaped the aviation system of today, our current portfolio is setting the foundation for the next 100 years of aviation innovation. Business as usual is not going to guarantee the United States' preeminence in the global market, nor will it enable us to meet these challenges. We must stay with our proven formula of leadership through technological superiority. NASA Aeronautics has a unique and important role in that formula. Long-term revolutionary aeronautics research has long provided the basis for new concepts and capabilities leading to industry innovation and societal benefits. ARMD will continue its role of undertaking research and development that falls outside the scale, risk, and payback criteria that govern commercial investments. Thank you again for the opportunity to testify today. I look forward to answering any questions you may have.
Thank you, Dr. Shin. I'd like to recognize Mr. Filler now for 5 minutes. Mr. Filler?
Good morning. Chairman Babin, Ranking Member Edwards, and members of the subcommittee. Thank you for this opportunity to appear before you today to discuss the Federal Aviation Administration's Aviation Research and Development Portfolio. I am Dennis Filler. I'm the Director of the William J. Hughes Technical Center. I also serve as the FAA's Director of Research. In that capacity, I am responsible for managing the FAA's aviation research program. Aviation is a vital resource for the United States. To maximize the opportunities that the aviation industry provides, the FAA must not only maintain, but continually improve the National Airspace System, or NAS. Collaborative, needs-driven research, engineering, and development is central to this process. The FAA's research portfolio enables the United States to remain a world leader in providing safe, efficient, and environmentally sound air transportation. FAA research, and specifically research conducted at our technical center in Atlantic City, has contributed to making aviation safer, both at home and abroad. For more than 50 years, the FAA's world-renowned researchers, scientists, and engineers have developed technologies, standards, and procedures that prevent in-flight flyers and improve survivability. The National Transportation Safety Board recognized that the Technical Center's contributions in fire safety research saved lives during the horrific Asiana Airlines crash in 2013. In addition to making aviation safer, FAA research is making it more efficient. Key next-gen foundational programs such as ADS-B, ERAM, and DataCom have all been developed, tested, or began their nationwide deployment at the Technical Center through our unique engineering, test, evaluation, and sustainment activities. Collectively, these programs will deliver operational efficiencies into the National Airspace System. Our applied research is also delivering near-term benefits. For example, our research into minimum wake turbulence separation standards has allowed us to safely recategorize distances needed between aircraft, which increases efficiency and reduces flight delays. Because of Wake Recat, FedEx can take advantage of a 13% increase in departure capacity at Memphis. And at Atlanta's Hartsfield-Jackson Airport, Delta Airlines projects reduced delays will save $14 to $19 million in operating costs over a one-year period. Greater efficiency also reduces the environmental impact of aviation. The FAA is invested in accelerating new technologies that reduce fuel burn, noise, and emissions through the Continuous Lower Energy Emissions and Noise Program, or CLEAN. This public-private partnership leverages limited federal funds to develop technology to make today's aircraft fleet quieter and more fuel efficient. Aviation is constantly evolving, and there will always be a need for applied research in response to these changing needs. That is why we are conducting robust research around new entrants to the airspace, such as unmanned aircraft systems, or UAS. Recently, we announced the selection of a new Center of Excellence for UAS, which will be led by a team from Mississippi State University. This Center of Excellence will focus on research, education, and training in areas critical to the safe integration of UAS into the nation's airspace. Also, as part of the Pathfinder program, we're leveraging industry interest in UAS applications to further explore other integration opportunities. The trials performed under this program could yield valuable data to further FAA-approved UAS operations. While we respect our past and its legacy, our vision is firmly fixed on the future. We're committed to ensuring that the United States continues to lead the world in the development and implementation of aviation technology, while we continue to operate the safest and most efficient aviation system in the world. This concludes my statement. I'll be happy to answer your questions at this time. Thank you.
Thank you, Mr. Filler. Thank you very much. Now I recognize Mr. Lieber for 5 minutes.
Thank you and good morning. Mr. Chairman, Ranking Member, members of the committee, thank you for the opportunity to speak to you today on issues concerning civil aeronautics research and the FAA reauthorization. I'm here today in my capacity as one of the co-chairs of the committee of the National Research Council, which recently reviewed a FAA research plan for certification of new technologies. That report was requested in the FAA Modernization and Reform Act of 2012, was released on Monday, June 8, 2015. Mr. Chairman, before commenting on the findings of our report, I want to make clear that our committee had a very narrow and limited charge. We were asked to review and comment on this one research plan. The FAA has many other plans for research and for other aspects of implementation of NextGen. We were not asked to and did not review those other plans. Our committee found that the February 2014 certification research plan does not demonstrate how integration of aircraft, ground systems, procedures will occur in the National Airspace System. It, in particular, omitted any substantive discussion of the air segment. Successfully demonstrating how integration will occur will create confidence in the implementation and, we believe, attract stakeholder and operator investment. Mr. Chairman, our committee believes that all stakeholders will benefit substantially from the explanation of the end-to-end processes necessary to certify, approve, and implement advanced next-gen capabilities beyond the midterm, that is, 5 to 7 years. In our view, a new FAA plan should outline how the agency can best coordinate its research with other relevant organizations, particularly NASA, which conducts significant research of relevance on air traffic systems. I thank you for the opportunity to speak to you about this important National Research Council report, and I look forward to addressing your questions.
Thank you, Mr. Lieber. I recognize Dr. Hansman for 5 minutes.
Chairman Babin, Ranking Member Edwards, and members of the committee, thanks for the opportunity to be here today to talk about research, and it's important in aviation in the U.S. Research and development is vital to maintaining the safety, efficiency, environmental performance, and security of aviation in the U.S. and the rest of the world. The FAA oversees and operates the largest and most complicated national airspace system in the world. And it needs R&D to maintain and improve the performance of the system. As chair of the REDAC committee, I'll just mention some of the things that we have identified to the FAA. Pardon me, I have a cold. Some of the strategic areas that we think are important. One is, as has been mentioned, the integration of UAS and the NAS. Another, has also been mentioned, the efficient operational approval of new capabilities into the system to enable things like NextGen. So we have the technologies, we have to figure out how we actually get them operationally approved. Human factors of increasingly automated systems. As the Asiana accident represents, we have more automation in the airplanes. We have to understand how humans interact with these things, both in the air and on the ground. Data integrity and cybersecurity has also been mentioned. Cybersecurity is an emerging concern in aviation. It's been around for a long time. Some of the vulnerabilities may be overstated, but this is clearly an important area for research. There's also opportunities we feel to leverage big data. You know, the airspace system actually generates one of the nicest sets of data that's out there, and it gives us an opportunity to understand the dynamics of this complicated system. And also the other thing that the FAA needs to do is do research to be prepared to either use or approve new technologies as they emerge. For example, additive manufacturing, as we start to think about building airplanes with printing technology, do we have the understanding to make those approvals? Or the impact of portable devices, the iPhones and iPads that we all carry around, can change how cockpits and airplanes are operated. But there are systemic issues in terms of both vulnerability and how those would interact with the rest of the system. So we need to be doing research to support all those. I'm happy to take any further questions or talk in more detail.
Thank you, Dr. Hansman. Now I recognize Dr. Heislop for 5 minutes.
Thank you, Chairman Babin, Ranking Member Edwards, and distinguished members of the committee. Thank you for the opportunity to testify about the importance of the Federal Aviation Administration's research, engineering, and development programs to our nation's continued leadership in aviation. While I currently serve as Vice President General Manager of Boeing Research and Technology, I'm speaking to you as a member of the American Institute of Aeronautics and Astronautics, the world's largest aerospace professional society serving more than 30,000 individual and 95 corporate members. The FAA is of significant importance to AIAA, so I'm pleased that Congress is moving forward with legislation to extend the agency's programs. Reauthorization with adequate funding levels will ensure that our nation remains the world leader in aerospace innovation. I've gained a great appreciation in my career for the important role that research and development plays in driving innovation. It is imperative that we continue to make strong investments in R&D. Wherever R&D goes, innovation and economic growth follow. More than half of our economic growth is due to technological innovation, yet U.S. government R&D as a percentage of our GDP has fallen by 60% since 1964. In contrast, China's R&D investment is the fastest growing of all advanced countries and is forecast to overtake the European Union and the United States by the end of this decade. It is important to note that when we fail to invest in new R&D programs, we risk losing talent and expertise that has taken us decades to cultivate and would be difficult to reconstitute. Our engineering talent is not a fixed asset. It is made up of people who need challenging new projects. It is also important to note that declines in government R&D funding discourage young people from pursuing careers in science, technology, engineering, and mathematics. It is no mystery why U.S. engineering ranks were wide and deep in the 60s and 70s when U.S. R&D spending was strong and the U.S. space program was prompting countless students to pursue STEM careers. We're on the cusp of implementing a major advancement in transportation that could be just as exciting, a space-based air traffic management system. Creating such a system will have the kind of impact on air travel that the interstate highway system had on surface transportation. The next generation air transportation system will enable more efficient airline operations and yield annual cost savings in the billions of dollars. Now is the time for Congress to make a strong financial commitment and set a firm timetable for NextGen's completion. NextGen also is an integral part of the industry's plan for reducing airplane CO2 emissions. Commercial aviation accounts for 2% of man-made carbon emissions, but that percentage will increase as air traffic grows unless NextGen is completed. According to the International Air Transport Association, cutting flight times by just 1 minute per flight would prevent 4.8 tons of CO2 emissions every year. Sustainable biofuels are another important element of the industry's emissions reduction plan. Industry and government have partnered to create, test, and evaluate biofuels. As the supply of biofuels increases, their price will decline, spurring airline use. We've made good progress but still have a lot of work ahead of us. It is important that the U.S. government stay involved in the development of sustainable biofuels. The third element of our industry's emission reduction strategy is something the aerospace sector has been doing since its inception, developing ever more efficient airplanes. There are solid business reasons behind our work. Airlines always want greater efficiency. Now there are important environmental reasons as well for lighter, more aerodynamic airframes and more fuel-efficient engines. Government has important roles to play in these efforts, so it is vital that Congress continue to fund long-lead research projects related to airframe and engine efficiency. Finally, it is important that the FAA keep up with and enable the pace of innovation occurring in the aerospace sector. One program designed to maximize FAA resources is under study. Government and industry are researching how to move toward a systems engineering approach to airplane and engine certification. The end result of such a move would be a better, more efficient certification process, one that encourages innovation and accelerates the incorporation of innovative product enhancements. Over the last century, the United States has been synonymous with global aviation leadership, and we can continue that legacy, but we cannot afford to rest on our laurels and simply say, remember when research and development was a national priority. The research programs at the FAA and NASA are critical to the work of the men and women of AIAA. The realization of next-gen biofuels, more efficient jet engines, and lighter, more aerodynamic airplanes all require collaboration and partnership and a reliable stream of government investment in aviation's future. Thank you again for inviting me to speak here today, and I look forward to discussing this topic with you further.
Okay, thank you, Dr. Heislop. Appreciate that. And I thank all the witnesses for your testimony, and I recognize myself for 5 minutes. This question is for Mr. Filler and Dr. Shin. Since 2008, Congress has provided more than $1.5 billion in developmental projects intended to explore new concepts and evaluate alternatives to reduce uncertainty and risks associated with next-gen programs. However, unlike major acquisition programs, these projects do not have formally approved cost and schedule milestones and do not receive the program oversight given to other procurement programs. Last year, the Department of Transportation's IG office testified that the initial 2004 estimates of $40 billion shared equally by the public and private sectors could double or even triple. The IG's office also warned that the initial 2025 implementation date could slip by as much as a decade. Just this week, the IG announced a review of NextGen. In lieu of cost and schedule milestones, how do FAA and NASA ensure that this effort is on budget and meeting its objectives? Dr. Shin or Mr. Filler, whichever one of you would like to go first.
So NASA and FAA do coordinate through a variety of forms. We also take in and make sure in our research efforts, Dr. Shin is a member of our R&D Advisory Committee. Through the program he mentioned earlier, the ASTS, we also work on research efforts in that form. We routinely receive products and technology transfers through the Research Technology Program, the RTTs, and integrate those into next-gen planning. Next-gen is not a static plan that has a finite destination. It is constantly evolving as time progresses, demands change, and likewise we adapt to our programs. But NASA and FAA do coordinate routinely, if not quarterly, I'll say monthly, okay, through a variety of forum and throughout all many levels in the agency to, in fact, make sure that we are constantly in sync with each other.
Yes, Chairman, thank you for that question. NASA, as I mentioned in the oral testimony, is the organization develops enabling revolutionary technologies. So we are indeed a country's depository for research and development for all types of aeronautics technologies. So in particular, on the air traffic management and safety side, we are heavily coordinating with FAA. And in fact, my perspective is FAA is the most important customer for NASA in the civil aviation side, and DoD is most important partner for us in the dual-use technologies. So as Dennis Filler just mentioned about RTT, and also I mentioned in the opening testimony, that it is a big change for NASA and FAA to work together through this RTT. I can share stories. Maybe 10 years ago, we used to develop NASA technologies and hoping that FAA will incorporate and implement that. Sometimes it worked, sometimes it didn't work, because we didn't have the coordination and collaboration from day one. So we changed that, and that's the essence of a research transition team, as I mentioned. So we coordinate from day one that FAA air traffic controllers, managers, technical people work together to devise the research plan together and update and refine. So just one quick example is that EDA, we call Efficient Descent Advisor. This is the technology that allows aircraft to have a continuous descent without throttling up and down and following the path that is somewhat of a reverse wedding cake, if you will. So that saves tremendous fuels and also reduce the community noise. So that type of technology could save $300 million per year in fuel savings if the technology is implemented across the fleet and at our busiest airports. So that's the kind of impact research that we are doing with FAA.
Thank you very much. I appreciate that. Our ranking member, a gentlewoman from Maryland, Mrs. Edwards, is going to allow the gentleman from Virginia, Mr. Byer, to ask the first question. I understand you have to leave, so I'll recognize.
Thank you, Mr. Chairman, and thank you, Ranking Member Edwards. Mr. Filler, I understand the FAA is starting work on a multi-year effort to update the scientific evidence on the relationship between aircraft noise exposure and its effect on communities around airports. This will be done by contacting residents by phone, by mail, and it's indicated that you'll not disclose which communities will be polled to preserve the scientific integrity of the study. According to FAA, a key goal of the survey is to determine whether the agency should reevaluate the noise metrics that it uses. And while I appreciate the need for scientific evidence, I remain incredibly concerned about the nature of the citizen complaints about the aircraft noise that not being well understood. I represent National Airport, and we hear this every day. As you know, aircraft noise is currently measured on a scale that averages all community noise during a 24-hour period with a 10-fold penalty, a noise that occurs during night and early morning hours. And while this methodology works if you're looking for a long-term average noise level, it doesn't help if you're trying to measure the noise impact of a plane that's flying over your house. In that type of situation, you want to find a way to measure peak decibel level and frequency. So, Mr. Filler, my question is, how will the study address those concerns? The inability to have a picnic in your backyard or have a conversation on your front porch.
So I know that these considerations are being evaluated right now in the FAA's Environment and Energy program. Specifically, I can't answer your question directly. I don't have the technical expertise personally in this domain, but I can assure you we'll be glad to take the question back and get you a more thorough answer.
All right, thank you very much. Dr. Shin, is NASA doing any research on reducing aircraft noise? What can we look forward to in the future?
Yes, that is one of our main research topics at NASA. As you pointed out, because the community noise is a big issue around the world, not just U.S. airports. And our issue is more acute because all the major airports in the U.S. are landlocked. So we have all the houses around the airports. And to compound that problem, as Congressman accurately pointed out, it is a perception issue as well. So it's not entirely scientific approach. So there is an international noise measurement standard, so we're following that to reduce the noise. But still, there is a strong concern about communities around the airport for airplanes flying over their houses. So we are working both from operational procedures, so how can we effectively route airplanes around the communities to land safely, but with less noise. So that's part of that EDA that I talked about, Efficient Descent Advisor. So operational side, we work on that, but also vehicle side, engine noise. We have just, actually Boeing should take credit to put that Chevron nozzle, which reduces the engine noise substantially. So we are working on also aircraft technologies to reduce noise.
And the Boeing headquarters here is right next to National Airport, so they're motivated. And Dr. Heislop, yesterday the EPA announced that it's going to try to regulate the emissions from airplanes. The notion that aviation is one of the fastest growing sources of greenhouse gases right now. What are we doing technologically and operationally to reduce the emissions from our aircraft?
Thank you, Congressman. And the committee or the company is very committed to reducing emissions, of aircraft, because we recognize we have that responsibility. There's a number of technologies that are in work, and I can highlight several. Dennis talked about the CLEAN program, which is a program we have done in conjunction, a partnership with the FAA, where we look at not only aerodynamic efficiencies to reduce fuel burn. We look at different materials. We just completed a flight test last year with a different kind of engine nozzle out of a ceramic material that will address acoustics. We've done a significant amount of work in biofuels, looking at various forms and sources for where those biofuels come from. And since the number one cost of operating an airliner is still going to be fuel, there's a constant drive from us and the engine companies to become more and more efficient all the time, which is really why things like the 787 Dreamliner and what really drove a lot of those technologies behind those aircraft and will continue to drive them into the future. So between aerodynamics and biofuels and new materials that would enable those, there's significant work underway in conjunction with FAA and NASA.
Great. Thank you, Doctor. And thank you, Mr. Chairman. Thank you, Ms. Edwards.
Yes, sir. Thank you, Mr. Byer. And I'd like to now recognize the gentleman from California, Mr. Knight.
Thank you, Mr. Chair. I appreciate seeing Dr. Shin here today. It's always good to see you and hear your testimony. I have a couple questions about where we are and where we're going to be in the next 10 years as far as airliner flight. It seems like for the last 40 years we've almost been stuck in the mud. In 1970, if I wanted to go across country, it probably took me 4.5 hours. Today it takes me 4.5 hours. We're much cleaner. We do this more economically, but we are a little bit stuck technologically. I know that NASA has done many programs. Back in the early 2000s, you did a quiet spike program that worked on dispersing the sonic boom and making it so maybe we could travel across the country supersonic at some period of time. Is that something that NASA is still working toward? Is that something that maybe the private industry, we have about 20 billionaires out there that are just driving to become millionaires by getting into the aerospace and space industry. Maybe we want to incorporate some of them too to look at this.
It's good to see you again, Congressman Knight, as well. Thank you for that question, because the speed will become important. As Chairman and both ranking member mentioned about growth in Asia Pacific region in mobility and the distance, as we call it, tyranny of distance will become an important factor in aviation. So to that end, we have been working, NASA has been working in developing low boom supersonic flight technologies. The focus on low boom is because currently we have a law internationally and also in the U.S. that doesn't allow supersonic flight over land. So unless we change that rule to certain meeting the certain target rather than complete ban, the private industry, I highly doubt that will jump into this venture. As you pointed out, that there are many private industry partners who would like to see this new capability. So that's where NASA is focusing, trying to develop scientific database that by design we can actually build low boom supersonic airplane, not through some kind of gimmicks, but actual design, and then provide that database to FAA and international rulemaking agencies, organizations, for their consideration to change the rule. Then I think our industry's ingenuity and the agility will provide that opening up the new capability.
Thank you. And Dr. Hyslop, I've worked with AIAA. It's a great organization. Yeah, hit me with one of the comments that you made about our STEM students and our engineering students, and maybe we're not as like we were in the 50s and 60s. I think that part of it is the advent of computers, that computers are very cool today, and a lot of our engineering students are going into that type of field as opposed to in the 50s and 60s. They went on to aeronautical engineering or something like that. Where do you think we're dropping the ball on this? Because I don't know any congressman or legislator out in the states that don't talk about STEM. It is the buzz phrase today. It is what we want. We are seeing the jump in young ladies being involved in engineering. I would venture to guess in 1960, if you were a young woman and you were becoming an engineering student, you were 1 in 1,000. Today, you're probably 1 in 5. So we've made huge advancements in that. And those are just don't look those up, but I'm betting that they're a lot closer. So where are we dropping the ball on this?
Well, that's a very good question, Congressman. I think I was at a STEM event with 5th graders in Houston a few weeks back, and we have to communicate to them, the excitement that comes from aerospace and working on these kind of products and being part of these kind of teams that bring these products to life. But I think you really, instead of focusing on the student, we really have to focus on the teachers, and we probably need to focus on the families to support the student. Because unless you take a full rounded view of that to make sure the teachers are comfortable teaching STEM type subjects at very low levels, and that the families know where to get, if they can't provide the support, they know where they can get help to help them support that student as they're going through those courses. In my opinion, I think we may be too focused on the student, not enough on the faculty and on the families, so that we've got a more balanced approach to the whole issue.
I appreciate that very much. Mr. Chair, I yield back.
Yes, sir. Thank you, and well stated. I'd like to recognize the gentlewoman from Maryland, Ranking Member Mrs. Edwards.
Thank you very much, Mr. Chairman, and again, thanks to the witnesses. Just a comment on the last discussion about STEM. The American Association of University Women just this last week, just a couple of days ago, released an amazing report about women and girls and their participation in STEM fields. And the problem that we're seeing really begins in about first grade, where for a variety of reasons, girls make a decision very early on that they are not science and math students. And so we have to disengage from that. But the problem is that it actually continues. The problem continues through the lower grade levels and then even into college and even in the workplace. Once a woman is in as an engineer, there are a variety of factors that lead to her making a decision that that's not for her. And so we have a lot to do, because the fact is that we are, according to this AAUW report, we are losing a significant portion of our economy precisely because women and girls are not engaged in the STEM fields. And the 21st century, frankly, is all about that, whether it's in aviation or others of our R&D fields. And so if there's some point at which we can have a hearing and really discuss the factors that are leading to that and how we can more greatly engage women and girls, that would be a good conversation. And the problem is particularly acute for students of color. And so we've got a lot to do, otherwise we're going to lose a major part of our workforce. Mr. Filler, I want to go back to this issue of the plan that was supposed to be transmitted to by the President to the Congress 2014 and 2015, because this is very problematic if we're trying to look at how we engage in this next generation of technology for aviation, but we don't even get the benefit in the Congress of a plan that's required by statute, not in 2014 and not in 2015. So can you give us a definitive date by which we can expect what has been due since 2014?
Yes, ma'am. As far as a definitive date, I can tell you that both plans have left the FAA. The delay was because we totally restructured both of these plans, and subsequent to that, the internal coordination required to clear the plans took much longer than what we ever anticipated. I can assure you that we have, in fact, started on the 2016 plan. All right.
Well, wait, I
And it's
mean,
entirely
Congress
our-
would like to see 2014 and 2015 before we get to see
Yes, ma'am.
2016.
And both 2014 and 2015 have left the Federal Aviation Administration.
Okay.
Okay.
I hear what you're saying. I guess I'm trying to figure out where we should drive to pick it up and when it's going to be delivered to Congress. And I don't mean to be flippant about this, but when we've required something by statute, it's precisely because we need that in order to be able to make an assessment about what we're doing on resource allocation and whether plans are going according to plan. I mean, one of my frustrations, frankly, has been that since I've been on this committee and in Congress, we've been talking about next gen as though it is going to be a transformation of the industry, and yet what we're hearing sounds much more like, you know, it's a little tweak here and there, a couple of upgrades, and not a transformation. Mr. Lieber, I'm a little bit curious about the nature of your testimony, because you focus very specifically on the limited scope that you had as the academies. How should your work and analysis really inform what it is that we're doing?
Thank you, Congresswoman. I encourage the committee to read the report thoroughly. We clearly had challenges getting information, and so it took a while for the FAA, first of all, to produce the report. Then we had asked for speakers. Some of our earlier meetings were unable to obtain them. Ultimately, we did have those speakers address the committee, and we appreciated that. But it was clear that to the committee that this research report was not given the priority we thought it deserved as something that the Congress specifically asked for in the reauthorization.
Do you think that there's a gap in terms of the FAA and NASA understanding the value of the academies in informing how we go forward?
Through the course of our investigation, NASA work with the Academy was cited repeatedly as exemplary, as effective. But yes, in answer to your question, Congresswoman, it appeared to us that there was a significant gap in the way the agency, the FAA, interacts with the Academy and the way NASA interacts.
Well, thank you, Mr. Chairman, and I hope we can explore further about the way that we close that gap, because we need the academies play an important role in us figuring out the direction and the critical analysis that needs to take place in terms of how we develop our R&D capability. Thank you, Mr. Chairman.
Okay, and I'd like to recognize Mr. Lobiando, the Aviation Subcommittee Chair on the Transportation and Infrastructure Committee.
Thank you, Mr. Chairman. My questions are for Mr. Filler. With cybersecurity being today and increasingly becoming extremely critical for us as a nation, Dennis, can you tell us what is the Tech Center doing today? What can it be doing additionally? What should it be doing additionally to help deal with this cybersecurity problem? And then I have a UAS question, depending on the time that's left.
Thank you, Mr. Congressman. In the realm of cyber, currently we are, in fact, working on research initiatives looking into the certification of aircraft technologies with cyber implications. In fact, how to take in, understand the current means and methods that are being employed, how software is developed, and then likewise how they are in fact tested and certified for use on board aircraft systems. So that is ongoing research that is happening. Recently, we have built a cyber test facility. We call it the SciTef at the William J. Hughes Technical Facility. Likewise, since we have the capability of every operational and developmental system within the National Airspace System, we are going to use the SciTef to look at new and emerging vulnerabilities and threats to existing and developmental NAS systems. Likewise, please keep in mind that every system that goes into the National Airspace System has, as part of its foundational building blocks, cyber concerns already built into every platform. So cyber is not a static threat. It is dynamic, and therefore it requires continuous evaluation and research to make sure that we can counter these emerging or zero-day threats, things that we haven't seen before. So again, what we're doing is actually turning the entire technical center into a cyber test facility where literally we can attack each of our representative systems with various threats to be able to find out how our systems respond and then what countermeasures we have to develop and put into our system to be able to counter what is a very dynamic situation. In the future, we need and continue actually to work and leverage technologies from DoD, from DHS, and anywhere else that the technologies, in fact, through cooperative research and development agreements, make sure that we continue to adopt these technologies and apply them, because that's what FAA research is all about, applying technologies that are out there that are commercially or developed through other governmental agencies that have the leads in many of these areas, and make sure that we are continually ensuring that aviation remains safe and secure.
So is it safe to say that for the FAA, the tech center is the tip of the spear for cybersecurity issues?
Yes, sir.
Okay. A follow-up question is there's a lot of excitement and a lot of discussions about the UAS integration into the national airspace. Can you tell us what the FAA Tech Center is uniquely qualified to do in relationship to UAS integration?
Again, on UAS integration, we have a UAS laboratory, and it has many representative UAS systems. Likewise, we have every system within the NAS, and so we are in fact exploring integration of UAS into the NAS by using very advanced simulation technologies to interact with the existing elements of the NAS and then also future concepts. So just last year, we completed a very extensive test program with the Department of Defense on integrating their UAVs into operation into the national airspace system. So it was very detailed, very exhaustive, very thorough simulation that went through many domains of flight and looking at ways, that, for example, the Department of Defense can safely integrate UAVs and use them into the national airspace system. So we do use a very exhaustive test methodology to test various proofs of concepts and see what works and what doesn't work to ensure that we have continued safe integration of UAVs.
Thank you, Mr. Filler. Mr. Chairman, thank you for the opportunity to sit on the committee. And as our committee moves to the actual presentation of the reauthorization bill, we look for a close working relationship in a very bipartisan way with your committee and the Science Committee to move forward. Thank you very much.
Yes, sir. Thank you very much for visiting this morning and your line of questioning. And also, I'd like to recognize this time the gentleman from Texas, Mr. Vesey.
Thank you, Mr. Chairman. I appreciate everybody being here today. And I wanted to ask Dr. Shin a question because I know that that UAS integration into the NAS is an important facet of your work. And how does NASA's work contribute to FAA's ability to regulate future UAS operations?
Yes. Thank you for that question, Congressman. We have started a UAS integration into NAS project about 5 years ago. So we have been developing, as I mentioned in the opening statement, the sense and avoid technologies, also communication and human-machine interaction, and we're also building a live virtual constructive test environment to test all the technologies. So we have been heavily involved in the rulemaking by supporting technical data in knowledge and technologies so that FAA and RTCA can make the rules within capabilities of the system. So that's what we have been working in very close partnership with FAA. Also, we have initiated last year for helping the community to allow safe and routine access of the small UAS at a much lower altitude, perhaps below 700 feet. That's where a lot of commerce interest is, as you've been hearing on the news media. So our role, again, is trying to provide enabling technologies and in partnership with FAA to allow these operations in a safe and effective manner.
And something else I wanted to ask you, too, is how do you envision leveraging the research results from both the COE for UAS and the FAA test sites?
Yes. Our project manager for UAS integration into NAS that I just mentioned has visited, and his team has visited all 6 FAA UAS test sites, and we are evaluating what sort of a partnership and collaboration is possible. And as I mentioned, we also are developing that live virtual constructive test environment where we can actually insert a virtual aircraft or manned or unmanned or also with a manned aircraft. And we can do this test at multiple sites across the country. So that's why we call it live virtual constructive environment. And I think there is a great potential for NASA to collaborate with these UAS test sites using that framework. And so we are actively looking into all possibilities.
Okay, thank you very much. My next question is for Dr. Hansman. Regarding the mixing of unmanned aircraft systems and manned aircraft operations, you indicate in your prepared statement that the future UAS operations will require formal concepts of operations and procedures for such mixing to occur. Specific to that research, you say that the REDAC is concerned that the, quote, fundamental work to support this has been deferred or neglected. Can you elaborate exactly on what type of fundamental work has been deferred or neglected and the implications of FAA not supporting this research?
Sure. So there are multiple classes of UAVs that have different requirements. So as Dr. Shin mentioned, there's a lot going on at the low altitude small UAVs. There is a current rule out for line of sight operations. There's work being done at NASA beyond line of sight. The bigger challenge actually occurs when you have slightly larger UAVs that want to operate in the airspace that manned airplanes want to operate on. And there's really, it's not clear what the right procedures are going to be. Are you basically going to treat them as manned airplanes, IFR targets, and have to operate under those rules? What happens when the operator loses communication with the UAV? What are the procedures and things like that? So this has been an area that's actually fundamentally hard, and people have been sort of doing the easy job, doing the low altitude job, and they haven't really dug in on the fully integrated UAV in the NAS. So that was the particular area we're worried about.
Okay. Thank you. Thank you very much. My time has expired, Mr. Chairman. Thank you.
Thank you. Thank you very much. I think we'll go back through one more time a line of questioning, and I would like to follow up with a little bit that has already been talked about somewhat. We're aware of many recent reports that individuals claim to have been able to hack into airline in-flight entertainment systems, taking control of aircraft's flight control systems. And while these claims may be greatly exaggerated, again, if you'd elaborate more than a while ago, what is FAA, NASA, and the industry doing to prevent this from happening? This is for Mr. Filler, Dr. Heislop, and Dr. Shin. And to follow that through, do you believe that government is doing enough? Because I noted in Mr. Lieber's report that NRC has mentioned that cybersecurity should be more of a consideration.
So
Mr. Filler.
Thank you. The FAA takes the cybersecurity threat very seriously. As I mentioned earlier, yes, we do have active research ongoing at looking at the increasing interaction of automation systems on board the aircraft and the use of interconnected electronics. The systems become more and more connected, and the interaction effects, provide opportunities for new threats to emerge and be able to have vulnerabilities exposed. We are looking to make sure that there are no vulnerabilities. So we are examining, again, in light of as the threat changes, then we're working with all of the agencies involved, to include intelligence agencies, on how these new emerging threats are coming out and making sure that our current airframes and systems are maximally protected. Again, though, it is a very dynamic and a very challenging problem that, it's not that when you get to point X and you are done. It's ongoing, just as each of us are equally aware of, we apply patches to all of our computer operating systems daily, if not at least weekly. Likewise, we'll have to make sure that all of our systems are fully secure. And so right now, we do have very active ongoing research to make sure that these threats are not posing any risk to aviation. And to date, we've demonstrated, very safe and efficient flight throughout the national airspace system. So thus far, we've been able to do a very good job.
Thank you, Mr. Feller. Dr. Heislop.
Yeah, Congressman. There's close collaboration across the industry to ensure the entire aviation system is secure from a cyber perspective. And the best practices and threat information is shared amongst everyone on a regular basis. Speaking now for my company, in the United States, Boeing has led the establishment of an Aviation Information Sharing Analysis Center. Members include Airbus, nearly all U.S. domestic airlines and Air Canada, and a number of other non-U.S. airlines as well as airports are considering membership. This group receives regular cyber threat briefings from all the appropriate agencies and the FAA, plus members are able to rapidly share emerging threats as they see on their own networks with each other. So there's a significant amount of interaction amongst industry and the governments on this important issue.
Okay, thank you. And Dr. Shin.
Yes, only a couple of points to add. As we are introducing, as Chairman pointed out, introducing more autonomous systems and more software-laden systems in the airplane, NASA is also working on verification and validation to help industry to develop the software not only cost-effectively but also safe and secure. And we develop a lot of software as well for control systems or other aircraft system. So we are also ensuring that our technologies will be secure and safe. That's one point. But the second point is through that interagency planning office that FAA is running in place of JPDO now has Homeland Security as a member. And so the overall and coordinated effort led by Homeland Security Department working with FAA and other federal agencies and industry, as Dr. Heislip mentioned. I think we are doing everything we can to make airplanes safe.
Thank you, Dr. Shin. And also, since the report was so critical, I'd like to let Mr. Lieber have an opportunity to give us his view there.
Thank you, Mr. Chairman. Yeah, we had a specific focus on confidence and timeliness of implementing things in the National Airspace System. We went through various aspects of the report, but there was a clear gap there, and it was not clear to us in the report itself, the 10-page research plan, that this issue was being adequately focused on. So we called it out in our recommendations.
Okay, sir. Thank you. And I'd like to go through one more time here for our recognize the gentlewoman from Maryland, Ranking Member Mrs. Edwards.
Thank you very much. I want to follow up with Dr. Hansman from the earlier line of questions. What are the implications of not having the research plan available for several years now?
So in terms of the NAR plan, is that what you're
Yes.
talking about? So within the READ Act, the internal elements have actually been briefed to the READ Act, so there has been internal communication. So I think that from that standpoint, there hasn't been a problem. There is a bit of a problem, which I indicated on my report, in that there are multiple lines of funding where research is funded within the FAA. So there's the R&D budget, there's also F&E budget, airports, NASA hubs. It's actually very difficult for us as the REDAC, and I actually think for the agency itself, to maintain a strategic view of its research portfolio because it's carved into different pieces, and there is clearly stovepipes within the agency, within different parts of the agency. So I do think that's a challenge for the agency itself, and then for advisory committees like REDAC.
And so that then leads to the next question. What do you think are the key issues and research areas that the committee ought to prioritize in the R&D section of FAA's next reauthorization, and why?
Well, so this is now to the personal opinion. I think that the expectations on REDAC or expectations on Next Gen are somewhat out of whack with reality, and probably always have been. I think that one of the things that's not appreciated is how difficult it is to make improvements to a system which is incredibly safe and actually reasonably efficient. So the real challenge we have is we have the technologies. There's no question we have ADS-B, we have all of the ground technologies. We sort of know what to do in the technical side. We actually have ideas on how we should operate, but unable to get those approved in a way that you can guarantee that we won't degrade the safety of the system is an incredible challenge. And I think that's why the report that Bill talked about, the intent of the Congress was to try to push the FAA to really think about that. I think that there is some institutional resistance to do that. And I think it's well-intentioned. They want to maintain the safety of the system. They don't want to be pushed. They don't want to do things that take risk. And safety is the number one priority. So
Because
I think
you're talking about developing not a parallel system, but integrating these new technologies into an existing system.
Yeah, you have an existing system that flies every day, 24 hours a day, that has accident rates that are unprecedented at any level of transportation. So when you come in with some wacko new technology that someone wants to put in and say, well, let's do this, the FAA legitimately says, well, wait a minute, okay, we need to do that. So do they have this is part of the reason for the importance of the research. They have to have done enough research so that they can say, well, no, you can't do that for this reason. They also need to think about, are there process ways that would allow them to test the technology, start to bring it in some evaluation way that would allow you to get it into the system, faster than 10 years now, 20 years from now.
Mr. Liebert, do you have a perspective about that or about other areas of R&D that should be prioritized?
Well, Congresswoman, I'm not sure I can improve on John's eloquent expression there. I think it was spot on. But I will just say that we have a cultural challenge, not a technological challenge. We have a communications, maybe, a communications challenge, I think. So we need to find ways to overcome the goodness that the FAA brings in its absolute vanguard of safety. They are beyond successful. And that goes for the entire industry, not just the FAA. But we need to overcome our communications and cultural resistance to change, because the world is going to change, and we're going to have to change aviation with it if we're going to lead.
And then, Dr. Hansman and other witnesses, if you want, do you have a perspective on the extent to which the Next-Gen Office, I guess as a coordinating kind of entity, is effectively carrying out its joint planning responsibilities? Is there another balance that needs to be struck?
I think the Next-Gen Office is actually, with its current administration, has actually been doing a pretty good job. They, because of the pressure and because of the fact that Next-Gen is behind and hasn't delivered, as you guys have indicated, have shifted to a short-term focus. So these are the things, they've clearly prioritized the things so that are short-term to get something on the table, get some results. I do have a concern that you then start to lose some of the long-term focus, and so you're not investing on the things that we need to do in the future or emerging opportunities or issues. So that would be the concern.
Yeah, I mean, I guess my concern, as I expressed earlier, is that sure you do these short-term things, but then it becomes a sort of system that's about upgrading as opposed to transforming.
If I could, I think the reality was it was always going to be an upgrading instead of transforming, that the expectations at the beginning were probably unrealistic. They were aspirational, and given the reality of implementation, the challenges of implementation, I think that you have to do this really at a worldwide basis, that some of the ideas were probably a little bit aggressive. So I think that, and part of this is we can't shut off the system, we have to run. So I think we actually have to figure out how to do effective, highly leveraged transitions of the existing system that will really improve the performance where we need it.
Thank you very much. Thank you, Mr. Chairman.
Yes, ma'am. Thank you. I'd like to the gentleman from Texas is gone too, and so is the gentleman from California. Yeah. So we will, if there's anything else, is there anything else we need to talk? I want to thank the witnesses for being here, for your testimony, and for your questions of folks here. And the record will remain open for 2 weeks for additional written comments and written questions from other members. So without any further ado, this meeting is adjourned. Thank you.